Numericals on real and apparent depth. The apparent depth of an object lying at the bottom of a beaker is 7.7 centimeter. If the refractive index of liquid is 1.3, then what is real depth? Let's consider the solution. We know that mu equal to real depth divided by apparent depth. We want to find out real depth. So real depth equal to mu times apparent depth. So mu is given as 1.3 and apparent depth is given as 7.7. So if we multiply, we will get 10.01 cm. Let's consider second question. The velocity of light in glass is 2 into 10 power 8 meter per second. By how much would an ink dot, there is space between these two words, ink dot, appear to be raised when covered by a glass slab of thickness 6 centimeter. So here we have to find out the refractive index of the glass. So mu is given by C upon V, and we know that C is 3 into 10 to the power 8 meter per second, and here velocity in glass is given 2 into 10 power 8, from where we get mu equal to 1.5. Now, here thickness of glass is 6 centimeter. It means this is a real depth. So a real depth is 6 centimeter, apparent depth is to be found, then normal shift is also to be found. So real depth divided by apparent depth equal to mu. Now we have to find out apparent depth. So apparent depth is equal to real depth divided by mu, that is 6 divided by 1.5. So this will give 4 centimeter. Now normal shift is real depth minus apparent depth. Real depth is 6 and apparent depth is 4. So it will be 2 centimeter. Let's go to next question. The bottom of a container is 4 centimeter thick glass with a refractive index mu equal to 1.5. The container contains two immiscible liquids A and B of depth 6 centimeter and 8 centimeter respectively. What is the apparent position of a scratch on the outer surface of the bottom of the glass slab when viewed through the container? Take the refractive indices of A and B as 1.4 and 1.3 respectively. So here, total normal shift can be found by considering the different liquids. So let's write the formula. So D will be equal to T1 times 1 minus 1 upon mu1 plus T2 times 1 minus 1 upon mu2 plus T3 times 1 minus 1 upon mu3. Here T1 is thickness of glass whose refractive index is 1.5. So let's write information. T1 equal to 4C1, 4Cm, mu1 equal to 1.5. Then T2. T2 we take the height of the liquid A. So T2 equal to given 6 centimeter and the refractive index is 1.4. Then T3, real depth of liquid B, and that is 8 centimeter, 8 cm, and the refractive index mu3 is 1.3. Now, situation is like this. We just draw a simple diagram. So this is suppose mu1 and thickness is T1. Then there is second medium mu2, thickness is T2. Then this is mu3, thickness is T3. So we can put the values. So T1 equal to 4 times 1 minus 1 upon 1.5 plus T2 equal to 6 times 1 minus 1 upon 1.4 plus T3 equal to 8 times 1 minus 1 upon 1.3. Now let's simplify. So this will become 4 times 1.5 means 3 by 2. So 1 minus 2 by 3 plus 6 times, this will become 10 by 14 or 5 by 7. 1 minus 5 by 7 plus 8 times, this will become 10 by 13. 1 minus 10 by 13. If we simplify, this will be 4 times 3 minus 2 divided by 3 means 1 by 3 plus 6 times 7 minus 5, that is 2 by 7 plus 8 times, this will become 3 by 13. So if we simplify, we will get 1.33 plus this will become 12 by 7, that is 1.71 plus this will become 24 by 13, so that will be 1.85, which will be equal to 4.89 centimeter. 4.89 centimeter, which is our answer. Thank you for watching.